Hello, everyone, and welcome to this Telit Cinterion webinar, In-Factory SIM Provisioning, Part 1, Global IoT Scalability. This will be a two-part series for IoT connectivity. I'm Amanda Flake, the head of global events here at Telit Cinterion, and I will be moderating our event today. To explain this topic, I am pleased to be joined by Jose Sanchez, the Senior Director of Product Management for IoT Connectivity and Services at Telit Cinterion. Thanks, Jose, for joining me.
Thanks, and thanks everybody for joining.
Now, just before I hand it over to you to start our presentation, audience, I do have just a few quick reminders. We will have time to answer some questions at the end of our presentation here. You can simply submit a question by posting in that questions box, which you could see near the bottom of your screen. Also, please be sure to check out the resources section for some additional information on our topic today. There you can find a few resources about our topic. And finally, we will send out this replay link to all attendees at the conclusion of the webinar. And with that, Jose, I will hand it over to you to start us off today.
Great. Well, thanks everybody for joining again, and welcome to this webinar. Today we'll talk about in-factory SIM provisioning, how to achieve global IoT scalability. Let's say today we are talking about a technology, an innovation that is one of those innovations that is relatively silent, right? You don't really see that, but it's really transforming, and it has a potential to transform many of the internals of how IoT applications are being built, they are being produced, and they are being delivered. And this is what we call in-factory SIM provisioning. So without further ado, let's look at what you can expect from today's webinar. So we're going to take you through, the challenges related to in-factory provisioning. We'll give you a deeper understanding of the stock keeping unit or SKU challenge. What is that, and why is that interesting, or why is that important for IoT companies? We'll give you a roundup of different solutions to help you achieve a single-SKU global cellular product. We'll explain what are the different SIM technologies that are available to use for your IoT deployment, and how that can be used to improve and resolve the SKU challenge. We'll give you insights into different standards from GSMA SCP-22 up to GSMA SCP-41. And in general, you will be able to get from this webinar why in-factory SIM provisioning is important for your business and what it can really do for your application. So let's move on and start with a few definitions to warm up, right? And this is important because there are often some misconceptions about the different terms used in the eSIM or EUICC space. So first of all, what is an eSIM or an EUICC? So that's also called embedded SIM, and that's basically a SIM card that supports over-the-air remote SIM provisioning. And we will explain what is remote SIM provisioning. But basically an eSIM, and this is a big misconception, an eSIM can have multiple form factors. An eSIM can be also a pluggable SIM, right? A plastic SIM, 2FF, 3FF. And it can also be a solderable SIM. It can be, there are multiple form factors, shapes and forms of SIMs that can be soldered onto a device, PCB. It could be MFF2, USON8, MFFXS, and others. So the word eSIM doesn't say anything about the shape or form of that component, right? It only says something about the ability to be remotely provisioned. What does remote SIM provisioning means? Well, remote SIM provisioning means that you're able to download over the air the required MNO profile. So not just the IMSI credentials, but the full MNO profile in line with GSMA specifications. That MNO profile is then linked to a subscription, right? And that subscription allows you to send data or voice, establish voice calls over a cellular network. The platform used to perform those services is called the subscription management platform. So we have a client, which is a SIM card, and a platform, the subscription management platform. So once we've clarified this, we can go a bit more into some of the challenges that we see today are relevant to many of our customers. When we work daily with global IoT customers or corporations that are using IoT technology to solve everyday problems, industrial problems, and they face issues related to scalability of and it's particularly related to the use of a SIM card, and they usually come from when we, in our discussions with OEMs and service providers, there are a few requirements that usually come up as being, standing out as being most important. First and foremost, connectivity must be seamless and global, right? You need to have global coverage everywhere, and this must be seamless, right? You must not be able to see any interruption of connectivity throughout the lifetime of the application. The device should be built in a single global SKU, right? So that is the ideal situation. You have a single device that you can ship anywhere in the world. And there's also a trend in the last, let's say, 10 years or so, and this is depending on the market. Some markets are moving faster, some markets are not moving that fast. There's a trend from plastic SIMs to solderable SIMs, of course, right? All this creates challenges. This means that when you move to solderable SIMs, you need to solder a SIM specifically for each mobile network operator subscription that you're using. So that means you need to create multiple hardware variants. Typically, when you deploy a device worldwide, for global deployment, you might need specific SIM subscriptions for specific countries that because of restrictions found in those countries, for instance, permanent roaming restrictions. And last but not least, some of our customers, they're already thinking about the next level, using eSIM, which is a SIM embedded inside a chipset, a cellular chipset, and so not offered in a separate hardware component, but inside the cellular module and chipset, and they need to embrace that trend. And that would, in many cases, mean that you will need to manage multiple SKUs of IoT modules, each one of them linked to a specific operator subscription. So again, this is a challenge, and this all creates the need for a solution. So if we go again a bit more in detail into what this challenge means, I'm trying to give you an example of an IoT device that's built by a company. For instance, a company building a connected two-wheeler, or let's say a connected e-bike, and this company needs to ship to 3 different regions. And because of the nature of business, they need to source 3 different SIM cards from 3 different mobile network operators. So, of course, they would need to create 3 different versions of the PCB with 3 different cards. That whole process and the maintenance of those SKUs generates additional R&D effort, manufacturing effort, and also logistic overheads, right? That is the challenge we're talking about. What are the consequences of this? The consequences are various. I mean, they start from higher product development costs. Your R&D troops, they would need to develop and approve and certify different product variants, and this increases your development costs. But also, of course, stock keeping and logistic efforts. If you have multiple SKUs, this increases your stock keeping efforts, and also higher manufacturing costs. You need to produce multiple product variants instead of one. Potentially also, this leads to longer lead times. If you need to manage multiple SKUs, it is less efficient, so that you have overall lower business flexibility and agility, and that might lead to having to accept potentially longer lead times. So customer satisfaction might be lower. So these are the problems we see. And on the other hand, what can we do to solve these problems? Well, this is where in-factory profile provisioning comes into play. Imagine a situation where a company X building a two-wheeler, a connected e-bike, for instance, builds the e-bike with a generic SIM card. That SIM card is an eSIM or EUICC, as we described earlier. Now, using an in-factory provisioning service, that eSIM is converted digitally into an eSIM for a specific mobile network operator as needed, right? At the very last stage of manufacturing, or even after the bike has been manufactured in some configuration center. That greatly simplifies logistics, because you only need to keep a single SKU. You use an in-factory provisioning service, and then you personalize that SIM card so that you don't need to first source SIM cards from different vendors. Second, you don't need to keep different products in stock. You only need to keep a single product in stock. So that's a clear benefit. Now, what are the technical specifications that support this in-factory provisioning technology, right? Because without a standard, it's very hard to rely on a vendor and to maintain that throughout time, ensuring interoperability across different solutions. So as of today, the GSMA is the organization that's setting up eSIM standards worldwide. And so this association, this industry association, has defined a few specifications, so-called GSMA SCP specifications. As of today, we have the so-called GSMA SCP 21 architecture and the GSMA SCP 31 architecture that are the two options our customers have to deploy an in-factory provisioning solution that is interoperable, that is future-proof. There is an evolution of that, which is currently being defined at the GSMA. The GSMA, this association, is currently in the process of defining the specification of the next generation of in-factory provisioning solutions, which we call GSMA SCP.41. We will go into the details of what that means, but basically the SCP-41 defines a new component we call Factory Profile Assistant and a new type of SMDP Plus server called SMDPF. And it allows an OEM or service provider to provision profiles into an eSIM without the need of a live connection to the SMDPF server, so that it can sustain periods of no connectivity in the factory. But let's go into more details later on. Now, once we have looked at the standards, we have looked at the challenges. Now let's look at the actual solutions that you have available and the options you have available to implement an in-factory provisioning solution. How to achieve a global single SKU connected product. So we have different options here. In today's webinar, we'll go through three of them. First of all, over-the-air activation via cellular bootstrap. Second, in-factory provisioning over a local LPA or IPA client. and the third one, in-factory provisioning over an SCP.41 factory profile assistant. So each of them have their pros and cons, and we will go into that later. But let's first go into how each of these options work in detail. All right, so we'll first discuss the over-the-air activation via cellular bootstrap. This solution uses a global cellular bootstrap, which is embedded in the eSIM. And what is a bootstrap? It's also called provisioning profile. That is a subscription that's inside the SIM card that allows you to transmit data for the sole purpose of SIM provisioning. This subscription cannot be used for something else. So in that case, the customer or the OEM that builds a connected e-bike with a generic eSIM and a cellular bootstrap will turn on that device. And at that point, the first step would be to establish a connection to the cellular network using that cellular bootstrap. At that point of time, the RSP service or remote SIM provisioning service is contacted, and a subscription out of a set of subscriptions is chosen and downloaded in step number 3 to the device. That uses the cellular network connection. So there are pros and cons to the approach. It's independent from setup, so it can work anywhere as long as you have coverage, of course. But on the other hand, this provisioning alternative, it takes longer than other alternatives. You know, it is a relatively slow process, and it consumes potentially energy. In a battery-operated device, you will need to consider this. And it's not ideal for setups in low coverage scenarios, right? So where you have a factory where you know that you don't have good cellular coverage, this is not a good idea. But it is an option for sure, which is very easy to start with, and it gives good results. Now let's move into the next option, in-factory provisioning over a local LPA or IPA client. So in that scenario, instead of using a global bootstrap, we use a specialized PC or workstation inside the factory that runs so-called IFPP client. This client establishes a connection to the SIM card through the SIM interface, and it also establishes a connection to the RSP services. So now, when the eSIM is connected to the IFPP client, it will download a profile over that IFPP client and using the factory's internet connectivity. In this mechanism, you will need a live connection to the servers. So this is only working as long as there is a live connection and as long as there is internet connectivity, right? So again, this has pros and cons. The pros are that the times are faster, so you really increase significantly the time to provision a SIM card, which is essential in high volume production scenarios. There is no dependency to the cellular network coverage, right? So obviously here there is no access through the cellular network, so it is more resilient. And it works also in non-GSMA certified environments. You don't need a GSMA certified factory to be able to use this client. So all in all, that's a great option to start with. It is fast. The setup is relatively simple, but it requires some setup as opposed to the over-the-air option. You need a PC in the factory, you need a workstation, you need to install this client, and you need some sort of connection, physical connection to the SIM card, right? And always on internet connectivity. So all in all, a great option also for companies that are moving from low volume to high volume and want to implement something that's available now. And this solution is, available today. Third option is more a future option because it's actually not yet available in mass production. That's what we call in-factory provisioning over SCP.41 factory profile assistant. This one follows the GSMA SCP-41 new in-factory provisioning architecture. It has a component called SMDPF and another component called FBA, Factory Profile Assistant. The difference here with the previous model is that we are able, let's say in the beginning of a manufacturing day, or at the end of the prior day, or in, whenever the operators are choosing, to download a list of profiles into a database inside the factory prior to the production. So we, let's say, can download 10,000 profiles prior to production and store them into the profile database. Now, when we establish a connection and to the FBA is able to flash those profiles into the SIM card and during the manufacturing without the need of a live connection to a server. That has some advantages, of course. You don't need a live internet connection in your factory. You can provision a SIM card without always on internet connectivity. The provisioning times can also be faster because there is no server-to-server connection involved. So the lag times are lower here. There's only a local connection between the FBA and the SIM card. And there is no dependency to network, cellular network coverage, and also very little dependency to the factory internet connection. You only need factory internet connection when you're downloading that database, but not when you're flashing that profile into the SIM card. And it also works in non-GSMA certified environments. The only hiccup here is that this solution is not being fully GSMA certified yet, and as of today, there is no clear timeline for the availability of that specification. We are working, with GSMA also to ensure that this specification is moving forward, and OEMs and service providers can enjoy this option very soon. But as of today, this is not an option that's available. So let's now do a roundup of the different options side by side. In terms of flexibility and location, so the over-the-air bootstrap is very flexible because it allows you to use to do provisioning anywhere as long as there is coverage of your cellular bootstrap. And that coverage, that bootstrap, is provided by your remote SIM provisioning service provider. So in terms of flexibility and location, the over-the-air bootstrap has big flexibility, whereas the other two options need an installation of a client inside the factory, which might be a bit more cumbersome. In terms of provisioning speed, the over-the-air activation is slower than the other two. The in-factory provisioning over SCP-41 is expected to be the fastest of all these options. And in terms of resilience to temporary outages, again, the SCP-41 is superior because it works also in times of no internet connectivity, right? So yeah, there are pros and cons to all options. We also need to take into account the availability. These two first options are available and can be used today. The SCP-41 option won't be available before 2025. So, here we need to balance and consider these timelines, and before we decide for one or the other option. In general, my message here is, you have an option. You can start today to use in-factory profile provisioning and simplify your IoT project. As such, in Telit Cinterion, we have an eSIM provisioning offering that comprises 3 different elements, 3 different parts. One of them being the in-factory provisioning. It's a dedicated offering along with eSIM activation and eSIM lifecycle. So the eSIM in-factory provisioning is a solution that uses an LPA in factory. So basically follows the second option that we have presented today. The over-the-air activation is also available as eSIM activation. So now we can go into a bit more detail on the eSIM in-factory solution by Telit Cinterion. So we provide a portal and an in-factory provisioning tool by which a service operator can enter GSMA activation codes that represent the different subscriptions. And then by programming rules, you can automate the same provisioning process in factory. Also, of course, we offer modules, IoT modules with and without embedded eSIM that make the process and the task of building a global, unique SKU much easier. We have this global EUICC solution paired with in-factory provisioning solution. We believe it's a great match to help your companies build global products and manage the SIM logistics in an easy way. We would be very happy to have you test our product and get your experience, get your feedback, and in the end of the presentation, we'll share a link that is for sure going to be of interest to all of you. Before we finish the presentation, let's wrap up by summarizing what is in-factory profile provisioning and what are their benefits, right? So in-factory profile provisioning is basically a set of technologies that allow OEMs and service providers build connected products in a single global SIM SKU, personalize that SIM SKU at the very last stage of the production of or the manufacturing of your IoT product, and ensure that you can simplify logistics and streamline your production. The benefits are, first of all, a fully digital process based on the latest GSMA standards. So no more sourcing different SIMs, a global product variant based on a single eSIM from a single vendor. Streamline production, right? Enhanced scalability. A single product in stock, and you decide the MVNO or MNO profile after your customer order is received. And you can increase that as you need. And last but not least, increased overall process efficiency, lower development efforts, lower manufacturing costs, shorter lead times. So as said, this is one of those innovations. It's one of those technologies that really transforms the way IoT applications and in general, industrial SIM-based, applications and cellular applications are built. That is often overseen, but we believe it's very important for all OEMs, global OEMs, and global service providers to take into account. So now my last message to you, if you scan the QR code in this page, you'll be able to request a starter kit. And we encourage you to speak to our IoT experts and get started today. So without any more to say now, I'm wrapping up my presentation, and I thank you for staying up till the end. We'll have now a Q&A session. So thanks for listening, and yeah, over to you.
Thank you, Jose. Before we get to the questions, audience, I am going to drop a poll on your screen as well. If you have maybe additional questions about the starter kit, about anything that Jose went through today, please just respond here on the poll, and we'll be sure to have somebody reach out to you directly. As Jose said, we do have time for a few questions, and we did receive a few, so we're just going to dive on in here in the few minutes that we've got left. Jose, the first question that I have here, we are a company that provides global fleet management solutions using cellular technology for many years now. What aspects should I look to assess the need for in-factory SIM provisioning?
All right. Well, like we've mentioned earlier, global applications, they often need to use different SIM cards from different MNOs, IoT MVNOs. I would recommend to assess the situation when it comes to number of SIM suppliers used today, number of MNOs or MVNOs used today, first assessing that situation. How is your SIM production and or SIM insertion in the device being done today? Is it a plastic SIM, a cellular SIM? How many different product variants are you using? And is there a possibility to simplify that and to build a single SKU? It is really simple, right? I mean, this is something, it's an analysis that most companies will not take very long to assess the potential of in-factory provisioning, or the potential that in-factory provisioning has to simplify your logistics. So I would start by the number of SKUs you have built up to now, and assessing the number of different SIM cards from different vendors, and also doing an audit also of the factory to actually think about and quantify the effort spent today in managing the SIMs in your factories or in your configuration centers.
Great, thank you. Next question I've got, can you elaborate on the limitations of factory SIM provisioning using a global cellular bootstrap?
All right. Yeah, I think we mentioned a bit of that also. I mean, global cellular bootstraps are a great technology because they allow an IoT company to download an IoT profile from an MNO or MVNO anywhere where there is coverage, right? But that's at the same time, that's let's say the main disadvantage. If there is no coverage, obviously that limits the usability of that bootstrap, and that is one of the risks that our customers need to assess. We provide a global bootstrap solution that has a true global coverage. So we're confident of our the coverage of our solution, and but it's definitely an aspect. But the other aspect beyond coverage is timing. So obviously, as your business progresses and you start to produce higher volumes of devices, production time becomes critical. And obviously over-the-air provisioning is a bit slower than over-the-wire provisioning, because, well, simply the initialization phase of the cellular network connection might take a bit longer. There might be limitations due to coverage in some areas, etc. So you need to take into account the impact of the end-to-end timing of your SIM provisioning process and how that fits into your manufacturing flow today.
Great. This is an interesting question here. How do you see the adoption of SGP.41 by the industry? And in which time frame could we expect solutions out in the market?
Well, that's an interesting question indeed. I mean, SGP.41 has been defined, but this is not the end, as GSMA is still working to define the next document that will define this specification, and that usually takes time, because there are many different actors, different interests involved, and it's obviously a relatively it's a complex process. As of today, it's very difficult to give a date, right? We don't expect this specification to be completed before 2025 starts, so most probably not before second half of 25. And there's also a time needed by the industry to adopt that specification, so that definitely not before, I would say not before 26, we will start to see applications using the SCP-41 specification. Right? It's very hard to say, and to commit to a specific date. It's just our assessment, but I would not really think that applications will be there before before 2026.
Yes, we will see. Let's take just one more question here. How does eSIM fit into this picture? Will eSIMs be compatible with in-factory provisioning solutions?
All right, yeah, that's also another topic we could have probably included in our section in the very beginning. eSIM in itself just speaks about the form factor of the SIM. It's basically not a physical SIM as such, built in a separate component like a plastic SIM or a chip SIM as you know it. But this is built inside a trusted execution environment inside a chipset, basically a cellular module, right? So that as such, an eSIM can be also combined with eSIM technology, right? An eSIM can be also an eSIM, and it can host multiple operator profiles. So if the eSIM is also an eSIM, then it can be used for in-factory provisioning with the mechanisms we have described today, right? So you in your production process, without being GSMA certified, if the eSIM is also an eSIM or EUICC, it means that it can be programmed. So it means that you can use it for in-factory provisioning, right? So that's really a step or an evolution that we expect to happen in the next years. Companies moving from physical SIMs to eSIMs, and then again, what I mentioned in the beginning of the presentation, if you want to work with multiple SIM cards, it's today you just need to order different SIMs from different MNOs or MVNOs. But if you want to work with different eSIMs with different operator subscriptions, then again, a cellular module will have to be delivered with that operator subscription. So the situation gets a little bit more complex. This queue of the cellular module will have to be paired with the MNO profile. And now here's where the in-factory provisioning comes. That in-factory provisioning will become an essential technology when companies move from physical SIMs to eSIM, because of the reason I just mentioned, right? You want to still order from your IoT module supplier a module that's agnostic to the operator or MNO, and then program it with an in-factory provisioning solution to be a profile and a module with a profile from a specific mobile network operator. So again, this speaks to the importance of this technology in the years to come. That's why we think it's important to talk about it and to do webinars like this.
Perfect. Thanks, Jose. I think we will wrap there. Again, audience, scan the QR code if you are ready to get started. Take a few minutes as we end here to check out the resources section. There's a few different things there that you can check out. Jose, thank you so much for your time today, and thank you to everybody who joined us. Have a good one.
Thank you. Thank you, everybody.